Hey guys, I hope everybody enjoyed the workday Monday. We have 2 lessons this week on factoring. So in class pages, Unified Classroom class pages, you need to print off your new notes, okay? So our new notes, sorry, mine are 2 pages. I'd print it front to back, but make sure you get those ready printed. Reminder. You can use these notes on your final. Just a heads up, some of the problems on our notes could actually be the problems on the final. Not all of them, I'm just saying though, some of them probably will be. So that's why we're taking the notes, so you could use it on your final and it will make it nice and easy, and you guys should do well on that. Okay, so we're going to be filling out these notes, and here we go. Oh, that doesn't look right. Okay, so we are starting the idea of factoring. Okay, so we've technically factored before. When we factor, what we want to do is we want to break it down to its smallest primes. So real quick, factoring is to break it down to primes. And if you remember, primes are like 1, 3, 2, 5, 7 are all prime numbers, because the only thing that multiplies to those numbers are 1 in itself. Okay, so example of factoring like 12, if we factor 12, that's 3 times 4, and 4 is 2 times 2. So a prime factorization or factoring of 12 is 3 times 2 times 2. Okay, so that's the idea of factoring. We're going to do factoring with the distributive property. Okay, if you remember, the distributive property is saying that if you had like 2x plus 1, that you can multiply that across to get 2x plus 2. Okay, so you can multiply it or distribute it through. That's the distributive property. We are going to do the opposite. Opposite of that. It's a little blurry. There we go. Okay. So again, another example of a distributive property could be something like if I had 2x times 4x minus 1y. Okay, again, we're taking 2x times 4x is 8x squared. 2x times negative 1y is negative 2xy. Okay. So when I say GCF, we got to understand what that is. That's the greatest common factor. And when we say the greatest common factor, if I was to look at number, let's say 12, so 12 we know is 3, 2, 2, and I looked at the number 20, which is 5, let's do this up here real quick. So 20 is 5 times 4, just 2 times 2. So 5 times 2 times 2. So if we're talking about greatest common factor, I mean, we see they both have 2 the same, but they actually have 2 2's the same. So 4 would come out of 12 and 20. That would be the biggest number that would divide those evenly. So 4 is the greatest common factor of 12 and 20. Okay? So we're always going to be looking for that biggest number, or the number that's going to divide both of them, but we don't want the little ones, we want the higher end numbers. Okay, so let's look at how to factor. So to factor a polynomial using distributive property, first find the greatest common factor of each term in the polynomial. So if you noticed in here, 8 and 2 was the biggest, and they both had an x. So technically, if we were to factor this, we would take out a 2x. 2x is something that divides both of those evenly. Here, we had 2x plus 2. Well, 2 is in both of them. So if you notice, that's on the outside. So we're going to do something very similar. So let's look at 27y. 27 is 9 times 3. We got 2 y's real quick. And then 9 times 3 we could break down. I'm going to pause because I already know 18 is 9 times 2. So I could break down this to 3, 3, and 3, 3, but I already know that they both have a 9 in common. So sometimes we don't want to go all the way to the primes. Maybe we want to stop before then. So technically with 12, we knew that was 3 times 4. Can't see that, can you? And 20 we knew was 5 times 4. So we could just see the 4 right there for the greatest common factor. We can't always go down to the smallest, but if you see that they already have one in common, don't go down any further. So they have a 9 and a 9 in common, and we have 1y and 1y in common. So my greatest common factor for this one is going to be 9y. Okay, so with 9y as our greatest common factor, we go to our next part. Go. Okay, we're going to then write each term in the polynomial as a product of the greatest common factor and the remaining factors. Okay, this sounds very complicated, right? Or lots of words. Remember, a term is just each piece. So right here, 4x is a term, negative 1y is a term. Okay, 27y squared is a term, 18y is a term. Okay, we're going to write it as a product of the greatest common factor. Product, again, meaning multiplication. Okay, and the remaining factors. When it says remaining factors, okay, we have 9 times 3y times y plus 9 times 2 times y. And we already said our greatest common factor was the 9y. So when it says remaining factors, my remaining factors are 3 and y. I think I just spelled that wrong. Yeah, no, okay. And 2. So those are our remaining factors. So what we do is we take our greatest common factor, we write it down first, then we do parentheses, and then we write our remaining. So 3 and y. Okay, notice this plus, that's going to stay there. So plus, we have 2 remaining. So technically, we just factored. Ta-da! So, if we look at the last one, use the distributive property to factor out. So this is actually our answer, 9y times 3y plus 2. We're going to do just a quick check. 9y, 3y plus 2. If we check this and I distribute this in, 9y times 3y, well, 9 times 3 is 27. Y times y is y squared. 9y times 2 is a positive 18y. We should get back to the original problem. And that's how we factor using the distributive property. Okay, real quick, we're going to do these 2 examples. So 15 minus 3v. And you might already be looking at this going, oh, I already know what they have in common, which is great. So 15 is 3 times 5 times v minus, and then 3 is already prime, and v. So what are my, what's my common factor, or my greatest common factor? 3. So greatest common factor equals 3. So that 3 comes on the outside. And what do we have left? What are our remaining factors? That's a w. That could have been awkward because then we could have taken out a v, but that's a w. So I have a 5w. Okay, again, this minus remains. minus, and v is all we have left. Okay, if you do a quick check, 3 times 5w minus v, 3 times 5w is 15w, 3 times negative v is negative 3v. It works. That one was nice. Okay, let's look at this one. We have 7 times u times u times t times t. Okay, that's the 7u squared t squared, plus 7 times u times t times t. That's my 7u t squared, minus ut. Okay, in order for this to work, it has to be in every single term. So my brain wants to take this 7 out, but here's a 7, here's a 7, this one does not have a 7, so I can't take 7 as my greatest common factor because it doesn't belong, it's not, sorry guys, it does not exist in each one of these terms. Okay, so let's see what it does. We have 1u, 1u, 1u. Okay, this one has another u, but these do not. I have a t, and a t. These two have additional t's, but this one does not. So the only thing that all three terms have in common are u and t. So my greatest common factor is ut. So again, that greatest common factor ut comes on the outside, and then we just write down what's left. 7 ut is left. Okay, plus I have a 7t minus, okay, if everything comes out, what do we put? We have this minus just dangling here, and if I put 0 and I distribute this, I would get anything times 0, 0. So when you divide, because that's what we're doing, is we're dividing ut out of each one of these. What's ut divided by ut? It should be 1. So if you ever pull out an entire term as the greatest common factor, you put a 1 there. And then let's do a quick check. Sorry, I'm going to box this so I knew that was my answer. And I'm going to put this as my answer, but let's do a quick check. So ut times 7ut minus 7u, or 7t, sorry, minus 1. ut times 7ut. So that'd be like 1 ut, 1 times 7 is 7, u times u is u squared, t times t is t squared. 1 ut minus 7t, 1 times negative 7 is negative 7, and that should be positive, sorry, goof there. And then 1 ut, okay, times, so 1 times 7 is 7, u times, no, u is u, t times t is t squared. So far so good. 1 ut minus negative 1 ut is negative 1 ut. Okay, and it matches the 1, technically is there, but we don't write it. Yeah, so that's it for today. You guys always know that my first one is the longest one. But hopefully you guys are having a great day, and I will have a new video up Thursday. So this week we have work days Monday, Wednesday, Friday. So enjoy. Hopefully you guys enjoy tomorrow. It's supposed to be super nice outside, and yeah, have a great day. Okay, bye.